Go is a statically typed language. Every value has a fixed type that the compiler knows at compile time. But Go also lets you write code that barely mentions types at all because the compiler can figure them out. This episode covers Go's variable and constant system, 4 declaration forms, the type inference rules, 0 values, and iota, one of Go's most useful but least understood features. Go gives you 4 syntactically distinct ways to declare a variable, and each has a specific place where it's the right tool. Form 1. Full declaration. This is the most explicit. You state the keyword var, the name, the type, and the value. Use this when you want the type to be obvious from reading the declaration, or at the package level where equals isn't allowed. Form 2. Type inference with var. Same keyword, but the type is omitted, the compiler infers it from the value. The variable is still fully typed. You're just letting the compiler handle the bookkeeping. The inferred type comes from the literals default. Integer literals give you int, floating point literals give float 64, strings give string, booleans give bool. Form 3. Grouped var block. Useful for organizing related package-level variables together. You'll see this frequently at the top of a file for configuration values, global state, or error variables. Form 4. Short declaration. Equals this is what you'll write 90% of the time inside functions. The walrus operator. Equals declares and assigns in one step, with type inferred. It's concise, it's idiomatic, and it's Go's preferred style inside function bodies. 2 restrictions. Equals can only be used inside functions, not at package level. And all variables on the left side must be new. At least one must be freshly declared. You can mix new and existing with equals when assigning to multiple variables. You can declare and swap multiple variables in a single line. Go's type inference is not dynamic typing. The compiler determines the type at compile time from the literal or expression on the right side of the assignment. Once set, the type is fixed. The rules are consistent and worth memorizing. Integer literals default to int, not int32 or int64. On 64-bit systems, int is 64 bits. If you need a specific size, say for a network protocol or interface with C code, you must say so explicitly. Type inference also applies to equals. When you write x equals some function, the type of x is whatever some function returns. No guessing, no ambiguity, the compiler knows. One practical consequence. Untyped integer constants in Go can be used with any numeric type without explicit conversion, because they carry no fixed type until they're assigned. But once assigned to a variable, the variable's type is set permanently. Static typing caught a bug before the program ran. That's the point. In many languages, uninitialized variables contain garbage, whatever bytes happen to be at that memory address. This is a source of entire classes of bugs. Go takes a different approach. Every variable is initialized to its 0 value the moment it's declared. What are their values? Exactly what you'd expect. I is 0, F is 0.0, B is false, S is, P is nil. 0 values aren't arbitrary. They represent the meaningful empty or not set state for each type. Numeric types. 0 Boolean, false string. Empty string, not null. Go has no null strings, pointers, slices, maps, channels, interfaces, functions, nil arrays, all elements 0 structs. All fields 0 recursively. This has practical consequences. A counter you declare but don't initialize starts at 0, perfect for incrementing. A Boolean flag starts false. The right default for not enabled yet. A struct you declare gets all its fields sensibly initialized. The one trap, maps. A nil map is safe to read from. You get the 0 value for missing keys. But writing to a nil map panics. Always initialize maps with make. We'll cover maps in detail in episode 8. For now, just remember, 0 map equals read-only. Constants are declared with constant. Unlike variables, they can never be reassigned. You can type constants explicitly or let Go infer. Untyped constants are special. They can be used with any compatible type without explicit conversion, which makes them flexible. Typed constants are stricter. Grouped constants using a const block are clean for related values. Constants can also use expressions of other constants, all evaluated at compile time, 0 runtime cost. The compiler evaluates all of this before your program runs. Every use of seconds per day in your code becomes the literal number 86400 in the compiled binary. Iota is Go's built-in constant generator. Inside a const block, iota starts at 0 for the first constant and increments by 1 for each subsequent one. No numbers written. No chance of miscounting. Add a day in the middle and everything still works. Iota becomes powerful when you use it in expressions. The expression is repeated for each constant, with iota substituted by its current value. The underscore discards the value. A Go convention for, I know this exists but I don't need it. Then KB uses bitwise shift. 1 shifted left by 10-1 is equal to 1024. MB reuses the same expression with iota now equal to 2, 1 I20. Perfect for byte sizes. Bit flags work the same way, where each constant is a power of 2 so you can combine them with bitwise or. This is the pattern Unix file permissions use, and it's the pattern Go's HTTP package uses for methods, OS for file flags, and many other standard library packages. One more thing. Iota resets to 0 at the start of each new const block. Independent sequences in the same file don't interfere. Go is statically typed but rarely verbose about types. You have 4 declaration forms. var with explicit type for clarity or package-level declarations. var with inference for when the type is obvious. Grouped var blocks for organizing related declarations. And equals the short form you'll use most inside functions. Type inference happens entirely at compile time. Defaults are int, float 64, string, bool. Specify explicitly when you need a different size. Every variable has a 0 value. No garbage, no undefined behavior. 0, false, or nil, always defined. Constants use const, can be grouped, can use expressions, and are all evaluated at compile time. Untyped constants are flexible. Typed constants are strict. Iota generates sequential constants automatically. Use it for enumerations, bit flags, and byte sizes. In episode 7 we cover Go's data types in depth, integers, floats, strings, runes, and what makes Go's string model different from most languages. See you there.